Hello guys, welcome to the new video again. In this video, we will discuss next lecture on finite automata. So, in this topics to be covered in this lecture will be closure properties for the finite language, for infinite language, and for regular language, for non-regular language. So, this is most important. From this, questions will come, right? So, let's discuss what is closure property. That there is a domain and O is operation. In this domain, with the operation is closed if and only if there are two elements in D x1 x2 belongs to D, whereas x1 or x1 operation x2 also belongs to D, right? So if not closed, x1, right? So let's take some example in mathematics. Operation, let's say plus, all right? So is n plus closed? So from let's take two elements from n. This is a set organized domain of natural numbers, alright? So let's say this is x1, x2 belongs to n. If x1 plus x2 also belongs to n, then it is closed. But this is the true condition. X always we can take any example. Let's say this 10 and 10 plus 8 is equal to 18, which also belongs to n. So this is true for n. Set of natural numbers is closed under plus. We are set of natural numbers is closed under plus. N is closed under plus. When we say plus is closed for natural numbers, there's many different. A is a natural number. We can represent n like this, and plus is closed. 1, 2, 3 dot dot n. We can say for infinite languages, which of the following are closed? Union, intersection. So let's discuss these things also. Union and intersections of domain set of finite languages. Right? Finite U, finite 2 belongs to finite. Finite 1 union finite 2 should belongs to finite also. And this is also so anyways. Z plus Z into Z minus also goes in this maths, right? So in mathematics, operation n minus is not closed because 2 minus minus is equal to minus 3, which is not belongs to natural numbers. So minus not closed, and divide is also not closed. Z divide is also not closed. Right? Types of domain: set of finite languages, set of infinite languages, set of regular languages, set of not regular language. Set of languages also. This is also types of operation in regular. We can say finite automata is union, intersection, complement, difference, clinical star, like these. Right? So for finite languages, union is closed, right? Finite, finite union finite is equal to is finite always, right? These are some very important topics which will come into, right? Intersection also closed, but complement is not closed because we can say complement, we can say is finite, no, right? So not closed for complement finite. For infinite languages closed for finite, but Right? Infinite or union or infinite is always infinite, but infinite intersection infinite will not always infinite. It can be infinite or finite. It can also on complement either finite or infinite. Complement is also not closed for infinite language. Closed proved by algorithm and it's not closed proved by example. So right. So if we want to prove that it is closed, so we will use calculator, right? If we want to prove this is not closed, we suggest just give an example for not closed, right? Yes. So let's start from here that infinite intersection infinite 2. So either finite or infinite need not be infinite, alright? Let's say this is infinite, this is also infinite, but in the intersection, this is infinite only, alright? So this is, we can say here is closed, but if this is a strict intersection, this is also infinite. So we want to prove not infinite, alright? So what we are doing here, a strict intersection B strict. This is the example. This is most important things to give examples, alright? Which is null. Alright, this is only common thing in this, but which is null is a finite language, alright? So infinite language is not closed under intersection operation. And example for this is also infinite and I'll complement for this. So complement is this, just give an example as we said. So L is equal to A plus B plus, so what we are doing is just bring L complement is equal to epsilon. So this is not, this is finite. So here this is infinite language and this is finite language. So what we done that here is that this is not closed under complement of operation also, because complement is epsilon which is finite. So yeah. Right. So let's some example, take some example A plus B est. Alright. This is infinite language. Infinite string it can generate, alright. But if we take this complement for this infinite language, so what we will do is uh, first of all this always start with the, so we can say yeah, B, all starts with B or not, we can say in this L, and one thing or is also not in here is epsilon also. So this is also infinite. So we can say a complement is either finite either infinite for this, right? Yeah. So over a strict b, a strict b, finite of one number of infinite languages. I don't know what we are saying. Just think. So complement of infinite language is either finite or either infinite. Right? Alright. Complement of finite language is always, complement of finite language is always infinite, is it? How? Complement of finite. Let's say L is A comma B. So what will be L complement is A plus B asterisk minus A comma B only. This is the complement for this. Alright. So always infinite. Complement for infinite languages. Language and languages. This is the only language. But complement of infinite languages is not closed. What we are saying that two languages are there. from the whole. But there are two languages we are giving. So two infinite language take two infinite languages and complement them, not closed, right? So complement for finite languages not closed also. Why? Because like this. Language and languages. So we will see it. Complement F1, F2, F3, F4, F5, F6. Is there any Fi belongs to D? Fi complement belongs to D. Finite, this is infinite here. Infinite, infinite, infinite. Complement for this will be here. What is complement of L? L complement is the universal language one side. So finite को implement for finite, that infinite minus finite. So it is infinite language. So for yeah, this is all always infinite. Alright. So complement L is here. Complement for this is it is infinite. This is finite. This is this. A minus A, infinite always. Alright. You can say here 1, 2, right? So epsilon, this is also infinite. So complements are right. So finite languages and infinite language closed under union. Is it union under infinite union and finite union? Finite is finite always, always finite. But intersection, union is good, but intersection is not closed. Complement is not closed, and here also is not here. Difference in finite language, is the difference closed? Yeah, finite minus finite is finite, but minus infinite, let's say, is not closed. How? Let's say that infinite is a strict minus 2, these are b strict. It would be what? No, I will say a strict a plus. So it would be epsilon. This is finite. Alright. So this is not closed. Difference is no concatenation for finite, 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 infinite, infinite, finite, infinite. Alright. Reversal. Reversal is not a big deal. Clean star is clean star for finite because clean star is makes is infinite, so does not make sense. And clean plus note, yes, subset finite, subset is not infinite always, because let's say yeah, this is not a cool thing. I mean, yes, this is not a cool thing. So let's say a star, b star is here, and we take a plus b star subset from this. A we take again. So now symmetric difference. What is symmetric difference? We will see it. This is a finite language noted infinite. Diva L. Diva amplified is L complement any language union. Uh, so what a finite L complement union L reverse. Let's say A B. This is the thing only. So a complement A star B star minus AB, right? Reverse BA, reverse B star. A star is not finite, and this BA. Union operation. Guises. So we will discuss the things we are here to discuss. So let's say union is here. So union F1 union F2 is belongs to finite. Finite union finite is finite closed. Right, intersection not closed. Is it? No, this is closed, but this is not closed. Right, and complement both are not closed. Either finite or finite. Alright, reversal concatenation finite, infinite. Concatenation what makes the difference? No. Reversal? No. Clean star it makes it either finite or infinite also, and always infinite. Clean plus infinite, not closed, not closed, and subset is finite, finite. So this is not closed. So yeah, difference could be there. Symmetric difference is what? Uh, Symmetric difference is L1 union L2 minus L1 intersection L2, or you can say L1 minus L2, right? Union L2 minus L1, right? You can see symmetric difference is it. Symmetric difference is not closed. Is it finite? So let's say AB is here. We'll discuss what is operation, how to apply in given domain. Closure properties for regular languages. Dot phi dot f dot set of all regular languages domain. Domain is set of all regular languages. Assume A, comma B. A number of regular languages we can generate from this. So let's say this is regular. This is also regular. Regular, 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 and regular is also refer to regular languages. So how can we regularize? Finite infinite is done. We are here to regular. Union, yes. Intersection, yes. Complement, closed under. Difference, closed. Concatenation, reversal, clean star, clean plus, symmetric difference. But subset is not here. Prefix, suffix, substring, substitution, L1. Homomorphism, shell, free homomorphism, inverse homomorphism, quotient 1 by 2 L, half of L, second half of L, one third of L, middle, last 1 by 3 of L, finite, and intersection finite, difference finite, concatenation, infinite, subset, finite F, but for infinite and subset and infinite. So for regular language, we can regular or subset infinite all right, and X is not closed. RXSI all RXSI union for regular language is closed. Regular union regular always regular, right? To regular language union regular expression to add in the between regular expression to expression language, all right. Let's say example that L1 is equal to this, L2 is equal to this. Both are regular. Use this. This is also regular. A star L1 any phi union any 2 is equal to L1. The regular is regular, irregular is regular always. Right. So L2, L1. Regular language, irregular language is equal to regular. Regular language is non-regular language. Other regular or non-regular. This is not regular, so it will be anything. Right, thank you so much. We will meet you in the next video. Thank you so much.